Hey guys, not quite done chapter 3. I separated it. So we are going to talk about today solving nonlinear systems. And this is section 3.5 in your book. Okay, so we are going to go ahead. So I have these sheets in the Google Classroom. You guys, it says here to work with a partner, but it doesn't on your sheet. You don't have a partner to work with. But basically, what I want you to do is take a few minutes here, take a look at your set of equations, right? And hopefully remember how to solve a parabola. And if you don't, graph a parabola. And if you don't remember how to do it, please take some time to go back into your notes and look to see how to graph a parabola in your standard form or in vertex form, okay? Because this will be coming up as we go here. So you're going to take a look. You're going to, capital A will go with a smaller case letter, all right? And then on your notes, it asks you to explain your reasoning. Just a quick little note would be fine. Okay. So this one here is solve the system by graphing. All right. And when you're graphing, please remember you need to have it into y equals. All right. So this case, you would have y equals x squared minus 2, and you would have y equals 2x plus 1. All right, you're going to go ahead and graph those two. And again, when we're solving, just like if we're solving two linear functions, we are looking for the point of intersection. Okay, this is a positive slope and this opens up. Remember our little things. All right, so again, take a minute, go ahead and graph. And hopefully you get for your two solutions because it intersects twice. -1, and also 3, 7. All right, and we can go over tomorrow if you have any questions with the graphing. Please make sure you're looking at your graphing calculator or Desmos if you don't have one at home on how to check these solutions. All right, so this next one is by substitution. All right, and substitution still holds the same way as with just your linear functions. Obviously, this equation is simpler to do for substitution. I'm going to notice that this one has an x squared, all right? So if I solve this equation for x, I'm gonna have to square the value, which I don't really wanna do. So I'm gonna take this equation and I'm gonna solve it for y. Okay, I'm gonna make it a little easier for myself. Sometimes you don't have that option. Sometimes you have to square the thing, but right now I have it, so I'm gonna use it. 4 minus x equals -1. So I'm going to be left with x squared plus 2x, and then bring over -3 is equal to 0. Okay, this happens to be factorable, which is nice. We get +3 and we get -1. So we're going to have two solutions here. Okay, so our first solution, we're going to have x equals 3. And -3. And our next solution is x going to be 1. So we're going to do what we normally would do, plug it back in. I'm going to use this equation here. So -3 plus y equals 4. So y equals 7. So this point, and the point of intersection, is -3, 7. All right, now I'm going to plug in 1. 1 plus y equals 4. So y equals 3 here. I write it and I say the wrong thing. So my point here is 1, 3. All right. And again, you can go take a look on Desmos on your graphic calculator, find those 2 point of intersections. All right, but this one was pretty simple to do by substitution. All right, our last one here is by elimination. If you remember elimination, we want to get rid of a variable. This is a simple one to do with elimination because we look at our y's. We have a positive and a negative. They just cancel out. We're left with, add our two equations, 3x squared minus 3x minus 2 equals -2. All right, and if we go to solve this, All right. I know it's not factorable because factors of 6 when added never will give me -3. Okay. So I'm going to use the discriminant here just to see if I even have a real solution. So that's 9 minus 4 times 3. And I don't really have to go any further because I know this is going to be a negative value, which means I'm going to have a negative under the radical, which means I have 2 imaginary solutions. And when we're talking about terms of solutions, that means there is no intersection. So no solution here. All right. Again, if you think about it graphing wise, right, these two just don't intersect. All right. So your homework tonight is going to be, I have it on a sheet of paper, this here. So do those 1, 2, 3. Explain the method that you are going to choose. Again, I have the sheet of paper that the fill-in notes are for. If you want to use that. If you don't have a printer, that's fine. Just go through it one at a time with it. All right. Hopefully the test wasn't too bad. I will hopefully have it graded for you for tomorrow. We'll have a discussion. Hope you guys have a good rest of your day. It's sunshine is out, so go out, take a walk around your neighborhood. I'll talk to you later. Have a good one.